This is Rachel Caraher. For my presentation, I chose addition. I chose addition because it is very important in the second grade. Second grade focuses on addition, subtraction, and other mathematical facts besides multiplication and division. So we're in the stepping stones of building off of first grade. In second grade, there are students who excel in addition and students who are still in the first grade level of not quite understanding their basic facts and do not have them memorized. The article I chose is The Importance of 10 Frames, so it really digs deep into what 10 frames are and why they should be used in the classroom. My article is about composing 10 with fluency and dialogue. In this article, the second grade curriculum focused on 3 main ideas, including understanding addition to develop quick recall of basic and related subtraction facts. The composition of 10 is the backbone of the curriculum. So what they mean by that is it is easier to count by tens to get to a number. So there are 10 tens and 100, 10 100s and 1,000, 10 1,000s and 10,000s. So it's the idea that a group is equal to 10. So this is in 10 frames. So 10 frames have 2 rows of 5. So they're little boxes with a circle inside representing a number. Through the 10 frames, students become dependent on rules rather than understanding the relationship of the numbers. So if students learned, so you need to add 3 plus 4 and never really understand the concept behind it, they will become dependent on, it's a near double, this is how I can add it. But through 10 frames, they relate it to the number 10. So they describe numbers in a tens group and some singles once they reach the age where they understand what basic 10 frames are. I'll dig more into that on the next slide. So how students begin to use 10 frames? So students began by relating each number to 5 and 10. For example, 7 is 3 less than 10. 9 is 1 less than 10. 6 is 1 more than 5, and 4 less than 10. So it is good to use relation to the number 5 to give the students an idea that, okay, I got 5, so I'm on my second row, but I'm not quite filled up with the second row. So how many more do I need to fill in the second row? In the lesson, when students were introduced to this concept, they practiced with flashcards. So one student will show a number. So they will say how many more would be equal to 10. So for example, if the card said 3, 7 is needed to equal 10. Students began to use the 10 frame when they had an add-in of 9. So as you can see in figure 2, there's an add-in of 9 and we are adding 8. The student would carry 1 of the 8 over to the 10, so that way is equal to 10. Since they took 1 away, there would only be 7 dots left in figure 2. This shows students that they can make a group of 10 and then add on what is left. This is supposed to be easier for the students to comprehend because 10 plus the number is equal to, say, 17, 27. So it's equal to the group of how many groups of 10s there are and how many singles there are. That is what it means by describing numbers in a tens group and some singles. So there would be 1 10 group and 7 singles. Some student misconceptions. So in the book, it said Henry and Brown found that the making 10 strategy contributed more to developing fluency with facts than using doubles. This is true. However, students need to know how to use the double strategy. Making 10 is not supposed to replace all strategies that are used. Students may pick this strategy to use, but is not meant to replace other strategies. All students must learn various ways other than Make 10. Make 10 was one of the very last ideas that I taught in my student teaching when we did doubles, near doubles, my way. I kind of wish they would have started with Make 10 because that made the most sense to students. This was also a very good way to show students when we reviewed how many different ways there are to add. A lot of them did choose to make 10, but all strategies were used when I was teaching. All other models used in the past have not been as successful in demonstrating this key relationship. So this is what I was thinking when we did our review in math for the unit. Yes, students did doubles, near doubles, but they couldn't explain their answer quite as well. They just said, well, 8 plus 8 is 16, not 8 is 2 less than 10, so I can make 10 out of that. Then I have 6 left, so it'd be 10 plus 6. So it's the idea of, okay, well, I have 10, and I took this many away, so now I have this many groups of 10s plus this many singles. Making connections. After students practiced relating numbers to 10, students began relating numbers to 20 and then beyond. For example, if I had 13 plus 9, I have one group of 10 already made. I have 3 singles plus 9 singles. So how many singles from the 9 do I need to add to the 3? So that is an example of relating to the numbers 20 and then beyond, because this can be used for any number. Students also began confidently using an open number line in this article that I read. So, for example, this student was trying to find 8 plus 6. So this student knew that 2 plus 8 equals 10, and I had 4 left over from that 6, so 10 plus 4 is 14. We did not use this example when I was student teaching with open number lines comparison to 10 frames, but I really like this and I will try to implement it in my second grade classroom. This article discussed the flexibility to allow for cognitive demand. So this means that students would be able to use open number lines if they understand the 10 frame concept well. As some students do not understand the 10 frame concept well, they can just use the 10 frames. So it's easy to be like, okay, so you understand the 10 frames, so go ahead and use an open number line. So it allows their brains to really be thinking. So students are always pushed as they can relate to numbers above 20. In conclusion, students had an increase in overall confidence in mathematics, especially in this article. And there is an emphasis on discovering relationships between numbers. That is meaning that it is understandable to be like, okay, so I need to take this many away to equal 10. So I have this many groups of 10s and this many singles. That's what it means between discovering relationships. Students began using these with place value later in the article, so 4 plus 6 equals 10. Therefore, 4 10s plus 6 10s equals 100. They also began using this model when making change for $1. They didn't discuss how they use this model for making change. They just said that they eventually did use this model for making change. So I would love to see that in a workbook of how they use dimes and nickels and pennies to make 10 frames to make change for $1. I will use this 10 frames for doubles in my second grade classroom. So in second grade they do, for example, 47 plus 32. You can use 10 frames for that. I have seen it. So I will try to use those, as it will work especially for lower students who may struggle with basic facts. So giving them that vision will help students succeed.